once you have forecasted using a weighted moving average, a moving average, maybe you've done some trend forecasting, or you've used another variable, so you've done some associative models for forecasting. Once you have your forecast, you can then measure forecasting error by looking at how that forecast compares to actual data. So in this particular example, we have sales for our lemonade stand, and we believed that the sales were related to temperature. That is, we would sell more lemonade on hot days and less lemonade on cold days. So let's assume that we have created an associative model using data prior to period 1. So we created a model. Now we have observed what has happened on period 1 through 15, and we can now compare it to the forecast that came from that model. So to calculate our forecasting error, we look at the actual, so our sales of 5 cups of lemonade, minus our forecast. So we find that on day 1, we actually sold 5 cups of lemonade. Our model that we created from data prior to day 1 anticipated that we would sell 12 cups of lemonade that day. And so we can see that our forecasting error is negative. That is, we forecasted higher than it actually was. We can calculate our forecasting error for all of these periods by pulling down the formula we created. So if you set the formula initially by clicking on the actual cell minus the forecasted cell, you can then drag it down and calculate it for every period. So here we have our forecasting error for each particular day. Now, to see how well the overall model works at forecasting, we can calculate what we call the mean absolute deviation. We can calculate mean squared error, or we can calculate MAPE. These are all 3 measures of forecasting error. MAPE stands for the mean absolute percent error. So let's start with MAD, mean absolute deviation. To calculate mean absolute deviation, the first thing we need to do is to find the absolute value of our errors. This means we're taking out the negatives. We're making all the numbers positive. To do this in Excel, you type in equals ABS, open parentheses, select your forecasting error and close parentheses. Notice that our negative 6.7984 became a positive 6.7984. And we can drag this down so that we can find the absolute error for all of the periods. To find the mean absolute deviation, all we have to do is do equals average, open parentheses, and highlight the absolute value of the errors. All we're doing is finding an average of those absolute forecasting errors. So we find that our mean absolute deviation is 3.1565. Well, is this good or bad? We know that the bigger the forecasting error, the bigger the mean absolute deviation will be, right? The bigger the forecasting error, the bigger the average of the errors. So to really see if this is a better model, we need something to compare it to. So let's compare it to a forecast, but this forecast is going to be a very naive forecast. That is, this forecast will assume that it doesn't matter what the temperature is, that our sales are going to be constant, and let's assume that we're always going to sell essentially what we sold the first day. Let's assume that every day we're going to sell 5 cups of lemonade. So we know from looking at this that it looks like it's not a very good model. So we can see that also in the forecasting error. So for our naive forecast, where we're saying that every day we will sell 5 cups of lemonade, let's find the forecasting error. So again, it is the actual, that's our actual sales, minus our forecasted sales. And so for that first day, the forecasting error is 0. When we look at the other days, we drag them down, we can see that we have quite a bit of forecasting error. To find the mean absolute deviation, we then find the absolute value of those errors, so equals ABS, open parentheses, and we highlight the forecasting error, close parentheses, and so we can drag that down. Although in this case we can see because we chose a naive forecast that was so low, we don't even need to find the absolute value because there are no negative forecasting errors. So then to find MAD, we find the average. And you can see that the mean absolute deviation is quite larger than it is for our associative model. Well, what if we chose a naive model that wasn't so low? What if we said our average sales, it's really going to be just 15 every day? So let's take our 15 for our naive, let's drag it down, and you can see that a naive forecast of 15 sales every day has an MAD of 6.9 compared to when we had the naive of 5 with a 14.4 for the MAD. So smaller MAD indicates that we have a better fitting model. And you can see when we forecast with a naive of 15 sales per day, then we do have positive and negative forecasting error, so that absolute value is important there. So to use MAD to measure your forecasting error, you need to be able to compare it to another forecasting method. Smaller numbers are better. How small the numbers should be, we can't really determine that with MAD because depending on what you are forecasting, the number will be bigger or smaller. So for example, here we're looking at 2-digit sales, and so our MADs are 3, 6, 9, so on. But if we were forecasting our sales and our company sold thousands of products, then the MAD is of course going to be a much larger number. It's going to be in the hundreds, even for a well-fitting model, because the forecasting errors will be larger. To prove this to yourself, you could add a 0 to all the sales, and you would then see much larger forecasting error and of course larger MADs. So you can only use MAD to compare different forecasting methods for the same data. Another method for measuring forecasting error is what we call MSE, mean square error. To find mean squared error, we need to take our forecasting error and we need to square it. The benefit of this method is that it's going to accentuate when we have a particular forecast that is way off compared to the others. So where the MAD treats all the forecasting error as equivalent, so when it just averages it all together, the mean squared error will put heavy weight on a single forecast that is way off. So when we calculate mean square error, we take our error and we square it. So let's take our negative 6.79 and let's square it. So that's a little caret sign above the 6. And we can drag that information down so that it will square all of our forecasting errors. And to find MSE then, we simply take the average of all those squared errors. We get 15.68. Is this good? Is this bad? Well, with mean squared error, you need something to compare it to. So let's compare the mean squared error for our associative model to the mean squared error of a naive forecast where we assume our sales will be 15 every day. So again, let's create another column. We'll call this E squared. And here we are going to take the error from forecasting using our naive approach, squaring that, dragging that down to represent for all the forecasts, and finding the average. So we can see that the mean squared error is larger for the naive approach than it is for our associative model, telling us the associative model fits better than the naive. Again, if we change the forecast for the naive to be 5 sales per day, we can see that the mean squared error for that model gets much larger, and we know that that is a terrible forecast to assume sales of 5 each day, especially considering that in 15 days we only had one day where we were as low as 5 per day. All right, so I'm going to turn that back to 15 so we can look at one more method. So let's look at the MAPE method. The mean absolute percent error for measuring forecasting error finds the absolute percent error. So we're going to use the absolute values, but now we're going to take that absolute value and we are going to divide that absolute value by the actual amount. So this takes the size of your forecasting error and puts it into context by looking at it as a percentage of the value of what you were trying to predict. This allows us actually to compare this model then to forecasting for completely different data sets, because with MAPE we can get a percentage accuracy. So with MAPE we don't actually have to have another forecasting method to compare it to. But just for fun, we'll do it for the naive approach so you can see how accurate it is. So we have the absolute error. Now we take that absolute error and we divide it by our actual. And we're going to drag that down. The other thing we want to do before we drag it down though is multiply it times 100 so we don't have to deal with lots of decimals. So we take our absolute error divided by actual times 100. Let's drag that down. Okay. All right, so then we are going to then find the average. And we find the MAPE is 26.33. This tells us our percent accuracy if we take that number and we do 100 minus that. Okay. Your goal is to have an MAPE over 70%. So we want to be at least 70% accurate, and in this case our associative model has an accuracy of about 74%. Well, how does this compare to our naive model? We can find that, so we'll create a column where we have the absolute error divided by the actual, and we are going to multiply that times 100. So take your absolute error divided by your actual sales times 100 and drag that down. Our MAPE then is the average of that absolute error divided by actual times 100. And so the percent accuracy then is 100 minus MAPE. And so we can see our naive method has a 57.5% accuracy. If we use the naive approach where we assumed 5 cups sold per day every day, you can see the percent accuracy drops even further down to 32%. So MAD, MSE, or MAPE can be used to measure the accuracy of your forecast. The benefit of the MAPE is that it doesn't have to be compared to other forecasting methods. If you take 100 minus MAPE, it'll tell you percent accuracy.